In this worksheet, we're going to talk about separation of variables. Separation of variables is the most common, one of the most versatile, one of the most important methods you're going to use to solve differential equations. What is a differential equation? It's just an equation that has a derivative in it, that's all. This is a differential equation because it has a derivative here, dy over dx equals ky. Now, this particular differential equation is very, very, very important. What does it say? It says that the rate, remember dy over dx, the derivative is a rate. The rate of growth is equal to k times the amount. Y is the amount. It could be the amount of money in a bank, the amount of bacteria, whatever. We're saying that the rate is equal to a constant times the amount, or that the rate is proportional to the amount. The more stuff you have, the faster it grows. And we see that all the time. If you have more bacteria, then every second you're going to add even more bacteria. If you have, say, 2 bacteria, maybe every minute you'll add one more bacteria. If you have 1,000,000 bacteria, then after a couple seconds you might add 1,000,000 more bacteria. So the more stuff you start out with, the more stuff you have at that moment, the faster the rate is going to be. And we know that from banks. You put more money into a bank, then you're going to get more dollars of interest, whether that's per second or per day or whatever. The more you have in a bank, the faster your rate of growth is going to be. In other words, the rate of growth is proportional to the amount of stuff that you have. Now, the equations that you see coming from this, you see them all the time. You have A equals A sub O times e to the kt. That means the amount equals the original amount times e to the kt. In banking and finance, we often say A equals P times e to the RT. Clearly, these are basically the same equation, right? That's the amount equals the principal, that's the initial amount, times e to the RT. In chemistry, we often write it like this, N equals N sub O times e to the kt. That's the same as the first one. Now, interestingly, all of these exactly identical equations come from the same differential equation, which is that the rate is proportional to the amount. In this worksheet, among other things, we're going to learn how to get from this differential equation to these very common equations that we've seen so many times. We're going to see that the rate is proportional to the amount ends up leading us to these equations. This is probably the most common, most significant, most important differential equation you'll ever see. You've already seen the results of it in pre-cal and econ and everywhere else. Again, all this is saying the rate is proportional to the amount.